So if you want to think about how many subsets a given set has, let's start with the very smallest set that we have, the empty set, where trivially, whenever we're dealing with a set, unless we're talking about proper subsets, the set itself must always be a subset. So, because the empty set has nothing in it, its only subset is itself. Which is to say, if we were to look at the empty set, its only subset would be the empty set. So we only have one subset. Let me actually do some more notation. Similarly, if I was going to talk about a set containing only one element, let's say the set containing the element A, we would have either the empty set, because the empty set is technically contained in everything. Everything can have nothing. And then we'd also have the set itself again. The set containing just A is technically a subset, so we'd have two of them. And if we go further, we talk about a set containing two elements, A and B, then we could either have the whole thing, AB, A, B, or nothing, for a total of 4 subsets. And if we had three things, we could either have all of them, AB, AC, BC, any of the one by itself, or nothing for a total of 8 subsets. Or the way we can think about this is in terms of the decision that we have to make at every single step. If you go through every element in the set, and when we're making a subset, we're essentially asking the question, do we include it? For these first two, there aren't really any decisions. But as you go further, we could think of that set of ABC as the set where we say yes, 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 or AB is yes, yes, no, AC is yes, no, yes, and so on down the line. That in each case, for each element, we have a simple yes or no choice with two options. So if we get down all the way to having n choices, that is, n elements, we have 2 for every single one of those choices. And this, again, I've mentioned it earlier, hints at an idea called the fundamental counting principle, which we'll get to later. But if you know any statistics, particularly the first couple of bits of statistics we cover at this school, then you'll understand the idea that if we have n things, n choices, where they're all distinct, and we have 2 options for each choice, then we're going to end up with 2 raised to the n total possibilities if we include proper subsets. Or if we include any subset, excuse me. If we have to do proper subsets, then we get all those choices except for the main one, where we say yes to everything, because we can't include that, in which case we just knock off 1, so we have 2 to the n minus 1 possibilities. Where, again, this is another thing that we'll talk about in a bit more detail later. We'll talk about that a bit more as we get further on in the semester, but the main thing to know here is that when we're determining the number of subsets, we can think about that in terms of very simple binary yes, no, 1, 0 choices, where we have n of them for a total of 2 to the n, or 2 to the n, that minus 1 should be a little bit lower, quantity, minus 1 potential selections. And that's basically all we have here for section 2.2. That's essentially all we have for this week. Next week, we're going to move further on into chapter 2. We're going to move further on here to talk about how we can visualize these things in a bit more detail, to get some more complex operations using Venn diagrams, and something that's inching towards an algebra of sense. But for now, let's focus on what we have here, get some practice in there, and we'll come back next week to talk about those things then. See you all in a little bit.